All right, so welcome to this week's Tea Time. I've started the broadcast, so we are live, and we have two speakers, Ian and Paul. Thanks for speaking today. First of all, I want to see if you guys are still speaking before I make that promise. So, Ian, are you still speaking?
Yes.
Okay, and Paul, did you have enough time to get ready? I know we have a big crowd.
I've been begging Ian to swap with me, so if he can do that, then I think I'm good to go.
Yeah. So Ian, would that be okay if you went now?
Yes. Give me just 1 second to get my code up on the screen.
Okay, great. I'm anxious to pass it over because I have a 3-year-old barge in a room talking about using the potty.
Okay. The screen should be up there. So I was actually hoping to go after Paul, just because my talk today is actually kind of inspired by Clojure and ClojureScript. Bit of background. Can y'all hear me? I'm not actually sure.
I can hear you. I can see your screen too.
Okay, great. So I was playing around with Clojure and ClojureScript, and it was interesting because I knew that JavaScript and Java both lack tail call optimizations, and it's of course Clojure and ClojureScript are both attempts to take Lisp and compile it into another language, and Lisp as a pure functional language kind of requires tail call optimizations because that's how you get by without having a loop. So for anybody who might not remember their functional programming, a tail call optimization, I'm just shamelessly stealing from Wikipedia here, is basically just a stack compression. And so in a normal factorial argument, you might get something like this, where you call recursively on down the stack until you hit 0, and that's your signal to stop recursing, and so then you return and collapse the stack back. And that's all fine and good as long as you are below your language's stack overflow limit, stack limit, which for Python is, I believe, something like 1,000 calls. I'm actually not totally sure. It's large, but it's definitely not infinite, and so that actually prevents Python from having truly functional designs that are safe and guaranteed not to hit a Stack Overflow error. So tail call optimization gets beyond the stack error by basically, instead of just simply calling the child function, the tail call function, we actually say just replace the previous. We go back to the previous stack call, and we just replace the arguments with these new updated arguments. So in this case, we're incrementing down, so 3 becomes 2, and since we've now multiplied by 3, this 1 gets turned into a 3. And then again, we turn the 2 down to a 1 and multiply 3 by 2, get to 6. But this all stays within a single stack frame, and so now we don't run that risk. And so you might be thinking, well, why doesn't Python have tail call optimization? That seems like a neat trick, and Python does support functional programming, at least to a certain extent. And the answer is because Guido does not want it. But he does have some good logic, mainly being that Python is always supposed to be very open and clear, and tells you exactly what you're doing and why it's failing as much as it possibly can. And the problem with using this optimization is that you will destroy the stack and therefore the stack trace, because it is a little bit less handy if you're constantly replacing the stack to then come back and ask, well, why did this go wrong? Well, we're not really sure because we collapsed like the last 200,000 queries that you made. But fortunately, after a few late night coding sessions, I figured out a way to hack in tail call optimization in a way that is fun and available for everyone today in Python 2.7. And so the crux of this is that I'm actually using a try and except clause to collapse the stack within Python's bounds. This is actually another reason why tail call optimization being added to the actual Python interpreter could cause some really nasty bugs, is because of try except. If you were to try except something and have the tail call optimization get triggered inside of the try except, it could lead to some really strange things where maybe your error no longer applies to the try except because you're outside of the stack now, that stack frame. But yeah, so this is just a fun little trick. I don't recommend using this in production anytime soon, because of the overhead of try and except, it does actually substantially increase your calculation time. I've run benchmarks on factorial done sort of the standard way in a for loop, and then in recursive, like using standard tail recursion, and then using this optimization. And while this will no longer hit the Stack Overflow at 30,000, it will actually print this number. You can open up. Oh, I should probably have had a shell running this already. It won't hit the overflow, but it will, unfortunately, take about twice as long as the other two methods, which are surprisingly close, given that loops generally do much worse than recursion. So this is actually up on GitHub. You can play around with it if you like. And it just uses a simple decorator. So you, if you want to add tail call optimization to a specific function and only that function, you add the recur anchor. And this is inspired on the recur function in Clojure, because this is actually how Clojure gets tail call optimization without JavaScript or Java having it. They have a recur function, and functions are all anchor points. So recur basically says go back up to the last anchor point that you hit and update these variables and then run it again. And so I've shamelessly stolen that, and you have a decorator here that will basically take your function and say whenever you get this particular type of exception, you're just going to run the same thing again with the new arguments that we were given by the exception. And so this is a hackneyed way to collapse the stack and update the variables. So yeah, that's pretty much all I had. Any questions? Don't see anyone on IRC.
Yeah, let me see. I'm checking IRC too to see if there are any questions. Any questions from anyone in the room? Okay. Well, thanks a lot for that, Ian, and giving that presentation on such short notice.
Sure.
Hopefully that gives Paul a little more to work with. Paul, do you need some more time, or are you good?
No, I'll dive in. I don't need to make people wait anymore. So thank you, Ian, for swapping places with me. That was helpful for me to just get a little couple pieces in place. And my thing is going to be fairly brief, but I definitely wanted to touch base on this because it's got me excited, and I think it's something that's can be interesting and valuable for, especially for Python developers, where we've got this wonderful language that can kind of do everything, and it's got very few sort of things that drive people mad about it, and so you tend to stick with it for a long time, and that's great, but there are lots of other things one can learn, and so it's fun to be able to sort of branch out a little bit. So I'm going to do a little sharing my window here once I get my presentation up. All right. So there it is. And come on, Google Hangouts. Pardon me. All right. There's up. Sharing now. All right. Do you see it? Looks like it's up. All right. So I'm gonna dive in. So I just kept the title simple. I don't pretend to be a sophisticated Clojure evangelist, and it's funny that Ian had that connection between his talk and doing ClojureScript. I found that a few years ago now, when I did a little tea time talk on Haskell, which I thought was my own little private thing. Of course, there were people listening who were like, "Oh yeah, when I learned Haskell, I did this." So that's one of the cool things about being at CMG is that there's lots of people who are keeping their sort of toes in the water, and I'm sure I'll learn things from people now that I've outed myself as diving into Clojure. So what's this all about? Back many years ago now. There's this cool book from the Pragmatic Programmers, which does cover Clojure among 6 other languages, 7 languages in 7 weeks. It's a nice selection. It's got a good set of languages that cover a broad number of things and sort of get at what I think is the cool reason to learn new languages, which is change the way you think, and it gives you ideas that you can bring to any general purpose language like Python. So 1 a week is a bit much for me in my current lifestyle. So how about 1 a year? So back in 2007, I said, yeah, I'm going to do it. This is so cool. And I was like, yeah, I'm going to learn Haskell. And I did, such as it was. I played with Haskell a lot and got really into it, and still have some things from that experience that inform my Python programming. My favorite quirky one is a sort of newfound appreciation for the semantic difference between tuples and lists, which I had formerly thought of as just sort of slightly different interfaces to the same kind of sequence. But Haskell, they're distinct types, and tuples is a set of things that are sort of come together, like the perennial example is the elements of a date. There's a year, there's a month, there's a day. You can't change their order. They have significance based on where they are, whereas a list is they're sort of homogeneous items all collected. And I didn't really have a handle on that until I played with Haskell that had a strict type system and had a fine clear line between those two. So anyway, Haskell, what's next? Let's see. Well, I got as far as 1 language a year, and then the next year all kinds of stuff happened and never got back to it. Life got in the way. So there I was, but I wanted to do again. So what I was looking for something that had certain attributes, and this is kind of a cheat of a list, but it's pretty sincere in terms of what I was looking for. I was sold on dynamic typing with Python, and I knew that I didn't want to just learn, let's say, Ruby. I talked to some people about learning a new language, and at that point, people were saying things like, this is back in the time when I chose Smalltalk as of interest. Hey, learn D. D is really cool, or whatever other things. Or how about Ruby? Ruby's way too similar to Python to give that effect that I wanted of the sort of change of thinking. They're really kind of sister languages that way. But I was stuck on a couple things about it. One was just the interactive shell in Python, where you can play around, you can experiment, you can learn fast and try things out. It's really, I think, goes hand in hand with a dynamic language. Python, we've attempted to shake the ground a little bit with different runtimes. So we've got the CPython, which is possibly a perennial reference standard, but there's PyPy and Jython and whatnot. But I thought there's something to be said for a solid runtime. I'm sure there was a counterexample that I was trying to avoid when I put that on my list, but now I don't know what it was. And no legacy baggage for sure. Python, URL lib2, and there's a lot of things in Python that sort of only got right the second time around, and the old one still stays. And I didn't want to learn a language that had a lot of you just do it this way, because if you do it the official way, it's a pain. And good for functional programming, I really wanted, because I was sold on that as a paradigm after playing with Haskell. I didn't end up running off with Haskell and doing anything particularly productive, but I really liked the mindset in terms of just sort of clarity of expression and also immunity to certain bugs. And so these were my criteria, such as they were. And so my pick was Clojure. And hey, look, there's the fancy Clojure logo. It's a descendant of Lisp. So it is a Lisp technically as a language. It runs on top of the JVM. Rich Hickey, who's the guy who created this language, had it did code generation. It generated, I think it had two backends. It had a C# backend and a Java backend that generated code into. So you wrote your code in Clojure, but then you essentially compiled it to C# or to Java and then ran it on whatever platform. That was, I think, a good sort of first step in getting it executable, but it didn't last. And so now Clojure just sits on top of the JVM. And I've never been a Java guy, but there's a couple great things about the JVM. One, it is sort of the winning platform in terms of runtime execution of languages. It's a great platform. It's solid. It's got a great deployment story for the web and for servers that need to run code. And what this means is that you got interoperation between Clojure and Java, so you can call whatever Java code you want. In fact, I have a friend here who ended up co-writing a Clojure book for O'Reilly after basically abandoning Python when Python 3 wasn't a radical enough change for him from the things he thought needed improvement in it. And he had a product that he had made that was very dependent on certain Java libraries. And so Clojure was a great sell for him because he liked the language and it could talk to the code he needed to talk to make his product work. So it's, for certain people, that's a big selling point. And finally, like I said, Clojure supports functional programming very well. It's not a pure functional language like ML or Haskell, but it is strongly oriented toward functional programming styles and immutability. Rich Hickey has this funny sort of incendiary quote that's, "Mutability is the new spaghetti code," and he's kind of on a tear against mutability. In other words, not knowing what a variable is holding until you inspect it at runtime. And Clojure has all these very sophisticated data structures that are immutable, so that if you perform a function that acts on one, what you get back from that function is not the same data structure with the new elements. It's a copy of the same data structure with the changes that you asked for, and it does all these clever, efficient things to make that not wasteful of memory and other things, and also embraces the fact that we now have gigabytes of memory instead of kilobytes of memory, and so we can afford to be a little bit freer in use of memory. But mainly, it's so that you can not have bugs introduced that are about mutability and not knowing at any given point what a value might have been affected by other threads and so forth. So, not pure functional programming, but it supports it well. So it's a Lisp. Many people who don't have experience with Lisp find that a little scary, but the funny thing is you can already read it. And here's my sort of baby steps of Clojure in the REPL. So that user prompt is the Clojure read, eval, print loop, or REPL, where you, like I said, just like Python, you type commands and they're executed. Any value just returns that value. So I type 1 and hit return, and I get back a 1 because that's the value I gave it, and that's what it evaluates to. The second one is function call. The structure is always in a list, which is what's inside parentheses is a list. The first element is a function, and everything else is arguments to that function. And so I say plus 1, 2, and I get 3. And I can give it as many arguments as I want. It's not a 2-argument function, but it's clear enough, right? You see that plus 1, 2 is 3. Got it. str turns something into a string. That's plain enough, very Python kind of functionality. And the last example is a function called first, and it takes a sequence, and that sequence in brackets is what's known as a vector, and that's what we think of in Python as a list. You can access elements by their index, so that's the way that arguments are passed to functions in Clojure. And so I say first of the vector 5, 6, 7, and I get back 5. So simple enough, and this definitely reels me in when I'm learning a language, that it has clear, sort of expressive and understandable and uncluttered syntax, and that's something that I think Clojure does really well. In fact, it has certain things that are designed to not to drive you to just scads of parentheses, which are the sort of the bane of some people's experience with Lisp. And then, just to give a few more shell examples here, this is kind of I picked one neat and curious thing about Clojure to demo here. I'm in the same prompt, and the first thing I type there is a map. So it's just like a Python dict, and those labels that start with a colon, those are labels. Ruby has a similar thing. This is something that Ruby essentially stole from Lisp, where I can have an arbitrary set of characters after that colon, and it's my key in this case to the value next to it. So when I type in that map, I get back the same map because that's the way it does it. Notice that when I typed mine, I didn't have a comma after the first pair, the first key value pair, and when I got it back, I did. And the order also changed. That's just like Python. Dicts are unordered. That's because we don't need them to be ordered typically. The comma is just worth commenting. Commas are white space in Clojure. You can separate arguments and elements with commas, but space is the true delimiter. Commas are just ignored, and so you will rarely see commas in Clojure code. They're accepted, but they're not necessary, and they just are one more thing to clutter it up usually. But it comes back in the REPL as a reply there as the value to distinguish the pairs, because otherwise it's just a whole lot of pairs of keys and values inside the curly braces with no punctuation, and that can be, if you're starting in the middle of a long one, harder to read without the comma. So the Clojure responds with the comma delimited version just for readability. So the curious feature I wanted to demonstrate with this slide is the second line, which is that maps are, I should put it this way, maps, keys in maps can be used as functions. There's a couple different ways to do this, but I just showed this one where I have a list, right? That's what's in parentheses. Anything that's enclosed in parentheses is a list, and the first item of a list is always a function. So I put in one of the keys as a function. Now, I haven't defined that anywhere. There's no other preamble to this. This is literally the entire session is in this little purple box. I gave it the first element as the key, and then as the argument to that function, I'm calling it, is that exact same map that I had above. And so with the key, as suddenly is now a function because I've put it in the function position in the list, takes the map as argument and looks itself up in the map and gives me the value that corresponds to that key. So I know that's kind of a surprising oddball thing, but it turns out to be a handy piece. And a lot of this, I'm a sucker also for sort of clear, consistent data literals in programming languages, and this is a nice one. This particular thing lets you do some things in a pretty concise way. And that is all I got. I wanted this to be a short one. I encourage anybody who's interested to jump in, and I just sort of the closing shot and link here is to lineengine.org. Lineengine is a general purpose tool for Clojure projects. A lot of it is about managing projects and all the code attached to a project, but it also gives you the standard Clojure REPL. And so even if you don't get to the point of building Clojure projects, you can still fire up Lineengine, and there's your REPL to play around with things inside Clojure. Oh, there's one other thing I wanted to just show you, and this is just interactively. I'm going to pull up my terminal window and just show you, because this is, I think, is a Pythonic bit. I will show you how. Let's just do this. So I'm going to swap my screen from this one to that one, and so now I'm in my REPL that I fired up from Lineengine, and hopefully this is readable. And so this is the same place where I said 1 or plus, pardon me, plus 1, 2, 3, 4, 5, and so on. But this is something that's good for Pythonistas, is sort of something near and dear to our hearts, is we're trying to learn about something. There's a doc command. So in Python we say doc parentheses, and we give the name of the, or help rather, parentheses, and we give the name of the item. In Clojure it's called doc, so I can say, what's the docs on, I don't know, the string function. So I've made a function call here. The function is doc. The argument is this str function. It's built in, and boom, there it is. Clojure functions actually have doc strings, and that's where this help is generated from. And just as a closing bonus thing, all the sources there too. You can literally say source cr, let's say, and that's the actual source of that function, including its doc string here. So there's the doc string as the first item after the function definition, and that's the code. There's no other piece hiding away. This is the code of that part of the Clojure language. So it's all inspectable, and it's all written in Clojure. So I'm going to close there. Anybody's free to ask me questions. I've said most of what I know, but I encourage you to check it out if you're at all inclined.
Any questions for Paul? All right. Well, thanks, Paul. So, Alan, you made some. I think maybe you two can talk right now, because Mason had an issue where he's trying to do some testing in IE, and Alan, you can kind of use Charles at the proxy web service software to do testing. Like, you hook it up to your local environment, and you're pointing to live sites. So maybe you two could talk to see if that's something you could accommodate him with.
Yeah, sure. I could show how I did this. Maybe this could be used by someone else. So maybe I could do a screen share. Let's see. So what I did is, when I was working in my local environment in Moreau, I was using it to load locally, but I thought that I could take the compiled CSS and map production sites CSS to my local CSS using Charles, and that way I can see the CSS as if I put it in production. So this is what I did in Charles, and it has this map local. You can map a resource on the web to a local file. So I did two of these files. Like this is an example of one. So on our premium sites, this is the path for master CSS, and I put the star in here to replace whatever changes between the CSS file. So the star is a wildcard, and it maps to my local CSS compiled in Moreau. Right here, you can see this. And so whenever I navigate to a live site, like my statement, I haven't worked on my statesman in production, but this is the live URL, and what it does is it takes my CSS and it replaces the CSS on the site. So I can reload it and show you. So we have these red links, and the styling is a little bit different. And I can show you when I turn off the map local what happens. So I'm going to turn off map local and reload it. So it has the old style with the blue links, and so this is red, and the padding is a little bit off, but it's the style that we're going to replace now. So what I did is I just mapped this one file, and it works for all premium sites, this path, and reload it, and I got the new style. The padding's fixed, the headers are no longer red, and all my changes you can see as if they're in production. And it works through all premium sites, so my AJC, my Statesman, my Palms Beach, and Dayton Daily News. The one thing you have to do is to, first of all, I'm using Sublime Text to change my CSS. You can use any CSS, any text editor, but I'm changing the less files, and I'm using a grunt command, grunt watch premium less. And so anytime I change a file in Sublime and save it, within a few seconds I can just reload any page in production, and it will show my changes immediately. This way you don't have to have a limited number of pages on your local machine or an FE. You can just view it as if it's in production. So that's all I had. Are there any questions?
Hey Mason, to that point, is this something you could use to help you?
I mean, that's a really cool thing to have, actually. I think I'm gonna set up something like that just for my own testing as well. But I don't think this is gonna help me with the issue I'm having right now, because what I need is there's an issue that's only happening in IE 11, and there's a line that's that's breaking, and it's stopping the rest of the script from running, and that's what's happening. What I really need is somehow to ignore that line in the debugger mode, somehow either change a variable on the fly or just skip over the line, but neither of these is available to us in developer tools for IE 11. With Chrome you can do that. I've done that before. With Chrome you can change variables on the fly, which is helpful. You don't have to deploy code in order to do some minor testing. But IE 11 being, the lovely IE that we all love, causing issues for us. Unless somebody knows of a really cool debugger that I can install on IE.
Yeah, I would say that as far as debuggers, IE is definitely not up to par with something like Chrome or Firefox, but they've come a long way, and it sounds like you should be able to accommodate that with the out-of-the-box developer tools that they provide. So that's something to look into. But if not, then I'm pretty sure there are some front-end gurus who have more experience with it. I would even say Kevin would be a good person to... actually, Kevin and Dan Kopp could probably assist too, as they have more IE front-end experience. And Alan, that was a great presentation. We really appreciate that. I'm definitely going to go back and rewatch that since this is archived. You know, it's like sometimes you can't deploy code to production to test, and you want to see how it looks, and you don't necessarily want to set up all this data and environment.
Yeah, it's helpful to do the map local, and it works for any file as well. It doesn't have to be CSS. You can do JavaScript or even the full page itself. So you can copy the entire page source, save it locally, map the file to the local page, and then make a few changes and see it as if it's in production. It works for any file.
That's a good piece of information.
Yeah, that might be helpful. Now, I'm doing this test on a virtual machine, so I'm going to have to do it, I guess. Yeah, I'll have to look into ways to make that work, I guess.
Okay. Well, is there anything else? That's pretty much all the presentations. Thanks, everyone, for presenting.
Thanks, everybody.
All right. Well, everyone have a good Friday. Have a good weekend. Take care.
Have a good week. Take care, guys. Bye.
You too. Bye.